One go. Hello everyone, I'm Hardik. Today I am going to tell you about our project of SIT 210, that is embedded system. A brief introduction, or as you can say a small introduction. Imagine a world where agriculture is not just a profession but a science-driven endeavor, where every plant needs to be monitored and optimized for maximum yield. Welcome to the future of farming with a smart greenhouse IoT system. Agenda. Our main motto is to create the best technology so that we will serve the mankind. I will tell you about our team members, the situation we targeted, website working, how it will work, and last but not the least, product design. You can see these are my fellow teammates as with description of their work, what they are doing. So let's start. I am Hardik as a web developer and circuit designer. My fellow mate Maulik as a web developer with Arduino tester and circuit designer. Last but not the least, Gurke is serving as the tester for all our sensors and greenhouse product design. The situation we targeted. As you can see, there is a beautiful article written by United Nations states that the population in 2050 will be reach around about 10 billion, and in 21st century it will cross 11 billion. It says that if the population rises, there will be crisis in the food crop. As you can see, due to a lack of proper maintenance for our crops, there will be destroying of crops. Due to that, the population that have raised may cause suffer or death. As my friend Maulik will help you to understand about this page. So you can start, Maulik.
Thank you, Hardik. So the problem we are targeting is related to the food basic necessity. As in future, not only we would be targeting as the future prospect, but we would be also seeking about the current situation. As many nations so let's zoom on to the action hunger article. As you can see over here, there there are many countries over here. There are many children who are facing such kinds of a problem. And now let's see the country's name. So Afghanistan, Burkina, Nigeria, Somalia, and South Sudan. Now let's zoom out. So let's see further what our article told about. As you can see, the food is the basic necessity. These country nations although have the suitable conditions, but either due to the natural calamities or either due to their lack of a knowledge, they had to face such a large amount of problem in growing abundant crops. Not only abundant crops, but even they can't grow the crops that are really basic or the that are used to are used in day-to-day life. As these nations has also gone through the many catastrophe. As you can see, due to the lack of a hunger, many developing nations or undergoing superpowers have to go through a lot of skyrocketing rocketing food crises. In even currently G20, these kind of food crisis condition is also targeting. But we are not only talking about the the overall political prospect, but we are targeting about the problem, that like how the food is the basic nature that we need to cure. Like in we could establish multiple greenhouse all over the world with our small design, small device which could increase the crops and nor a single crop would die. So let's move on to the next slide. So now I would be telling about how our basically design, our basically product would be working. So we would be using a dynamic website is a website which could be changing on based on your action. But here the action is done using your sensor. The sensor value would be on your screen. As you can see, based on the OSI model, in our own ecosystem that we are designing, there are layers included, but not all OSI layers, as multiple layers are also indulged in Firebase API. Now you would be thinking, what is an API? API is an application programming interface. So this kind of interface is basically helping our application as giving a side hand. so that a programmer has not to do such kind of work. All he has to do is to include all the inbuilt code in his website, so that he could get the credentials of all over the world. We would be using the Firebase because Firebase is an world trusted, and it also been made by the Google. It consists of the SSL certificate. Now would be thinking about what is SSL certificate. SSL certificate is secure sockets layer. Secure sockets layer is basically protecting our data while the transmission of a data from a website to the Firebase, as its data is totally protected, and we would be using the real-time monitoring. Now we would also be giving the user a as an offer, so that if in case of certain condition, like a plant is getting a so much water, low water email, then would be using the IFTTT, which is a webhook, to send the email, so that in case of an emergency, email could be sent, which is totally making the automation fully automated. The Raspberry Pi would be consisting of the screen on which our website would be hosted, and all the commands are sent to our Arduino, and there is an action and a value communication which we would be doing. So now let's move on to the next slide. So here are the sensors that we are using. So there is a communication between an Arduino Nano and Raspberry Pi. Now my friend Gurkirat will continue and told you about all the sensors.
Thank you, Malik. Certainly, we are using number of sensors in our prototype, starting with the soil moisture sensor. So, what is soil moisture sensor? It measures soil moisture to prevent over or underwatering and optimize irrigation, ensuring plants receive the right amount of water. Next, light intensity sensor. It will measure light exposure to adjust plant placement, promote photosynthesis, and prevent damage from excessive light. Moving further to the pH sensors, it will measure soil acidity to optimize nutrient availability, prevent imbalances, and guide soil amendments for healthy plant growth. Raspberry Pi. It will process sensor data by connecting to various sensors via GPIO pins and running custom code to collect, analyze, and transmit data. It will also control greenhouse systems through GPIO-based relays or other interfaces, enabling automation of tasks like irrigation and ventilation. Next, LCD12C. It will provide user with clear and immediate access to sensors data by displaying it on a user-friendly LCD screen. Next, infrared temperature sensor and DHT22 sensor. Infrared temperature sensor will monitor temperature by detecting thermal radiation, crucial for ensuring optimal temperature levels for plant growth. DHT22 sensor will measure both temperature and humidity, providing essential data for maintaining the right humidity levels, which are vital for plant health. The last sensor which we are using is MQ135 sensor. It will monitor air quality by detecting various gases, including CO2, carbon dioxide, and volatile organic compounds, VOCs, ensuring a healthy environment for plants. Moving to the next slide. So, talking about the product design, our product design is making the product eco-friendly and play the vital role in eye-catching, as it is must be easy to use all easy changeable circuits, so that it can be helpful for the user also. We use the 3D printing in our prototype later, which have the role to build the product with the recycled things, so that we can also contribute to the earth, as in the current millennium mostly products are made using the recycled things in our prototype. Key features of our greenhouse. We have taken recycled materials, environmental impact, and energy efficiency in our mind. So recycled materials, we are committed to sustainability by using recycled materials in greenhouse construction, reducing the demand for virgin resources and minimizing environmental impact. Our design will minimize waste and reduces the carbon footprint by employing efficient construction methods and eco-friendly materials, ensuring a greener approach to greenhouse production. Next, expansion and customization. Our modular design facilitates easy expansion and customization, allowing users to adapt the greenhouse to their specific needs and goals with minimal effort. Durability of our prototype. Our modular components are engineered for durability, ensuring a long lifespan and reliable performance in challenging weather conditions, enhancing the greenhouse resilience. The most important, data cable management. Our design streamlines data cable management, minimizing cluster and ensuring efficient data transmission between sensors and control systems, simplifying maintenance and troubleshooting. Improved air quality. Natural ventilation enhances air circulation in the greenhouse, aiding plant growth and reducing the risk of mold and disease by maintaining a healthier environment. The most important point, energy efficiency. The natural ventilation reduces reliance on mechanical cooling systems, leading to energy savings and lower operational costs, making our prototype an eco-friendly and cost-effective greenhouse solution. The next slide. So thank you. This was all about our project pitch. Hope you will like this video.